Okay, I want to work one more for you and show you why we have been using the conversions we used when we converted over to polar. If you remember, when we did our conversions over to polar, we said that we would, of course, change the function using our two substitutions here, x equal to r cosine of theta, y equal to r sine of theta, that we would redo the bounded region. But this was the important one, that we would change dA over to r dr d theta. And so what we were doing here was a change of variables where this here is the conversion factor, this extra r. And as a matter of fact, if we try to make this substitution using this, let's go ahead and calculate the Jacobian, because remember, when you do this double integral and you make this change here, this then should be the absolute value of the Jacobian that you get for making this substitution. So if x is equal to r cosine of theta and y is equal to r sine of theta, then the Jacobian of r theta will be the determinant of the matrix, which has across the first row the partial of x with respect to r, then the partial of x with respect to theta, and across the second row the partial of y with respect to r, and the partial of y with respect to theta. So that means we are going to use, in this case, again looking back at our functions here, the partial of x with respect to r will simply be the cosine of theta. The partial of x with respect to theta, the r is just a constant. When we integrate cosine, of course, we get negative sine. So this gives us a negative r sine of theta. Then we'll do the same thing for the y. When I differentiate y with respect to r, it just goes to 1 and we get the sine of theta. And then when I take the derivative of y with respect to theta, the r carries down and the derivative of sine of theta is cosine of theta. So I get r cosine of theta. Then let's go ahead and concentrate on this piece here. And so we see the determinant of this is going to be, remember we're multiplying this direction, subtract what happens, we multiply in the other direction. So I get r cosine squared of theta minus, of course, a negative r, which will make that a plus r sine squared of theta. And then if we factor out an r, that's going to leave us with the cosine squared of theta plus the sine squared of theta, which is equal to 1. And so we get then that the Jacobian, which we remember, absolute value, is the converting factor. That is where this r comes from.